Another neat trick is, say that you want to write something like this, but you want to do the move. So we want to move something, but we're not actually sure that the command that we're doing is completely correct. So we want to ensure that this is getting done correctly. One way of doing that is adding an echo in front. So remembering echo just prints stuff that's following after it. So now we can see what's actually going to be done when we're executing it. So what will happen when we're running this for loop is that 3 commands would be run. Move original basilisk to new original basilisk. By the way, these file names are terrible, and we'll show you in the version control session why and how and what to do instead of creating new original that reversed and so on. Yes, exactly. So this is an illustration of what not to do. Even though you always think you're creating the final version of some file, then you will always end up in a situation where you still have to make one final modification after you've done your final file and so on. So that's one of the problems that version control will solve. Now we've seen a little bit about how the for loops work, so let's go back to actually doing some analysis on those measurements data. So we go into the North Pacific directory again. And again, we remember that we wanted to look at all files that ended with an /ab.txt because we figured out that there were these .set files there was something wrong with, which weren't the right type of measurements. So if we do for data file in *ab, then we get one of those files that are ending in either a.txt or b.txt, which is exactly the ones that we want. And I of course have to put an in there. So that's the syntax. For variable name in, and then the list of things we want to match. And then again the do. So now I've just typed do, and then again echo to just make sure that we're printing out the right variable names. And then perhaps we want a statistics file with the statistics extracted from that data file. That's called stats, and then the name of the data file again, so that they're completely matched. And we can see that those files look as we expect. If we go down through the list, we've got all of these, and there's no one containing any C's in there, so that looks about right. Remember from earlier there were supposed to be 15 files, so we can verify that there are also 15 lines in this output by piping it to word count /L as we did before. So we just double checking that we're doing the thing that we expect to, and then we're indeed still processing 15 data files. *ab.txt still matches the same 15 files as it did the last time we were looking at it. So it looks like this is about what we want to do. Now we actually want to do something with the data files. So Nell has got a couple of different programs that she wants to run on the data files. One of them is called goostats, and the other one is called goodiff. So we want to actually be able to execute goostats on all of these files. So if we do, the way we want to run that is to do bash goostats. So that tells the terminal that goostats is a program they want to run, and we want to use bash to run that program, and then we want to run it on one of our data files, and then we want to output that into some other file. So if we want something like this, that takes a few seconds, and then it writes it to the output. So that writes some data to the output file. Now we could go back doing that manually for every single file, but obviously that's the thing we want to avoid, because this is really tedious when it takes 2 seconds and we have to redo it. It would be much nicer if we could do it in a loop where the computer automatically continued when it was done with the first file. So that's what we want to do. We want to replace the echo with actually doing something. So we do the thing we just did before. Bash, calling goostats, and then the file, and then the stats output file, and then we're done. And we just removed the word count that we had in here because we're not interested in that. And we actually wanted to do goostats and not goodiff. So now we're running this command. Unfortunately, we can't really see what's going on. We're just waiting and hoping that this will eventually finish. It's a bit tedious, so we can stop this and do something more clever. So if I press Control C then I break this loop and stop the execution. So it would be neat if there was a way to track the progress of this. One way of doing that is adding another line. So remember that we echoed stuff out before. So if we added a line here that for each analyzed files echoes out the file name, then we can keep track of how the analysis is going. Now we can see how it's going through each individual file, automatically continuing with the next one, doing the analysis. And now we're running this through 15 files, so that would be manageable to do manually, but imagine you had to do it through a couple of hundred files and every one of them take a couple of seconds. Yeah, that's probably a bit unfortunate that it's now running that on the stats files. That's because we already created the stats files, so we should probably have been a bit more clever. When we actually write a production script, then we probably want to make sure that the pattern we're using is not matching the stats, or that there are no stats files in there before we start. Because otherwise we're going to create stats files, which is obviously not what we want. Let's get rid of that output file as well, which was just some temporary stuff. We've sort of been using the terminal to interactively figuring out what we're doing and playing around with it. And we've been using the up and down arrows to navigate and go back and modify commands. Another way of looking at the things we've done is the history output. So history here will tell us all the last commands that's been executed. And that can come in handy because that means that when we've actually figured out what we want to run, then we can use history, and then we can go in and grab all those commands and copy paste them into a text file and and change this to be a script that we can actually run again and again and repeat this process, which is the next thing we'll focus on, actually to be able to write this into a script so that we can redo our analysis. You can have a look at the questions which are attached to this topic, which are down here at the bottom of the loops section.